All right, good morning. Here's our video for our 6D notes solving square root equations. Um, Pretty basic stuff right here. So if we're solving a square root equation by hand, we want to first get the root by itself. All right. So because you can't really take anything out of a root, so the only thing we can really do is get the root thing by itself first. So the root needs to be isolated, get everything else on the other side. Then we want to square both sides. All right. We'll square both sides and then solve. So next note, a lot of times these equations are going to end up being a quadratic. Remember, a quadratic equation is going to have an x squared and an x. Um, and when we have an equation like that, you cannot get x by itself and solve like you could any other algebra problem. All right. So a quadratic, when you have an x squared and an x, we have to be able to set the equation equal to 0, and we could either factor or use the quadratic formula. Okay. Again, the quadratic formula is better because it's just more comprehensive and it works for everything, whereas factoring sometimes works, sometimes doesn't, depending on what our solution is. Okay. Um, Now, with these square root equations, we can also end up with extraneous solutions. So we have to check for those. Um, once we get our solutions, a lot of times we'll have more than one, especially if we end up with a quadratic. And so, if you remember when we did absolute values back in the day, some solutions we do the math and we get them, and the math says that they're right, but in practicality they're not. The solutions are wrong, so we're going to have to sort of go back and check. So if we're looking at this equation right here, x plus 1 is equal to the square root of 7x plus 15. First thing we want to do, okay, the root is already by itself. Everything's over here. So what we want to do is square both sides. We're going to square that side and square that side. So over here we have x plus 1 squared is equal to 7x plus 15. X plus 1 squared becomes x squared plus 2x plus 1 equals 7x plus 15. Okay. Um, Again, we're going to have a quadratic here, which many of these times we will, especially if we have, the root x on one side and then we have an x on the other side where we're squaring it. But I'm getting ahead of myself. Let's first subtract the 7x and 15 to the side here, because we have to set the equation equal to 0 if it's quadratic. All right, so we're left with 0, and we have x squared minus 5x, and then 1 minus 15 is negative 14. All right, so we get x squared minus 5x minus 14 equals 0. If we were to solve this out, I think factoring would be the easiest thing to do here, because we could find two numbers that multiply to negative 14 and add to negative 5. So if we were to factor this quadratic out, going back to unit 4, and something that y'all probably did back in algebra 1, we'd have x minus 7 and x plus 2. Okay, negative 7 and positive 2 multiply to negative 14, add to negative 5. So x minus 7 times x plus 2 equals 0. So the math would indicate that our answers are x equals 7 and x equals negative 2. take a minute and copy this down. I'm going to erase this area over here. If y'all need to write that down, just pause the video if you need to. So we have our two answers, positive 7, negative 2. Now we got to plug them in to see if they both work. Okay, let's start with the 7. So over here, if we have 7 plus 1, that's 8. And then here we have 7 times 7 plus 15. Seven times 7 is 49, plus 16 is 15 is 64. So if we plug 7 into this equation, we end up with 8 over here equals the square root of 64. Well, that checks out because 8 equals 8. So 7 is a good answer. If we go negative 2, all right, over here we have negative 2 plus 1 on this side, and then we have 7 times negative 2 plus 15 over here. That should be a negative 2, not a negative 12. All right. So over here we have negative 2 plus 1, which is negative 1. And here we have 7 times negative 2, which is negative 14, plus 15 is positive 1. Okay. So here we have negative 1 is equal to the square root of 1. Okay. That's incorrect because the square root of 1 is 1. Okay. So what happens is negative 2 is an extraneous solution. Doesn't work. Okay. So our answer here is just going to be 7. This is the algebraic way of doing these things, and like what we did with absolute values and even a little bit with quadratics, we don't need to go that route if we don't want. Okay, we can bypass having to check for extraneous solution by using a system of equations. And we can just go into Desmos and do a system. So basically we take this equation right here, split it into 2. So here we'll have a y equals x plus 1 and y equals a square root of 7x plus 15. I'm going to show you guys here. So again, pause the video if you need to write any of this stuff down. I know I'm kind of going a little fast here, but again, trying to get you guys through this as quickly as we possibly can. So if we go here to our calculator, we have y equals x plus 1 is one of our functions. So that's one side. The other side is y is equal to the square root of 7x plus 15. Like that. Again, when we did the math, ladies and gentlemen, we ended up with 2 possible answers, right? We had positive 7 and negative 2. But when we see with the graph right here, there's only one solution. There's only one solution because these 2 graphs only meet at one spot, okay? And so here's one spot where they meet, 7, 8. All right, and we notice if we go to where x is negative 2, well, when x is negative 2, that graph is at 1, and this graph is at negative 1. Okay? So they're not the same. So the only solution is x equals 7. 7 is the only solution that makes this graph and that graph equal. Okay? So you can do the math if you want to do the math algebraically. I think it's probably a little bit simpler to graph these, but still a very good tool to have to do the algebra if you need to.
Yeah, I'm gonna work that mornings too now.
All right. So if you like doing the math, it's one way to check your work. Um, and if you want to just do it in the calculator, you have my blessing. Um, if we ever have radicals on both sides where you can't get the radical by itself, like we have here, we just have to square both sides. Okay, and we got to be just kind of careful when we do this. And so when we have x plus 2, the square root of x plus 2 plus 1 here, and then we have 3 minus x over here. So we still need to square both sides. All right, so what happens here is on this side, we're going to have 3 minus x over here. And then we have x plus 2 plus 1 squared. Okay, these ones I definitely would recommend just putting them in the calculator. That way we don't have to deal with it. But if we wanted to sort of do this, so we have so the 3 minus x, square root of 3 minus x squared becomes this, right? Just 3 minus x. X plus 2 square root plus 1, x plus 2 square root plus 1. So again, we sort of have to FOIL this. So x plus the square root of x plus 2 times the square root of x plus 2 just gives us x plus 2. All right. Then we have x plus 2 times 1, and then another x plus 2 times 1. So we're going to be left with 2 of those x plus 2's. And then we're going to have 1 times 1, which is plus 1. And so this side, x plus 2 plus 1 is really x plus 3 plus 2 root x plus 2 equals 3 minus x. Hang on. So if you were to do this again, squaring this gets one of the radicals away, and then we'd have to move the x and the x plus 3 over to this side right there, move the 2 over, and then repeat the process of getting this root by itself and squaring it. Again, kind of a lot of work. But if we did want to do that, so we have to minus this x, minus that 3. And so if we were to do that and minus x minus 3, what would we end up with over here? It would be negative 2x over here is equal to 2 root x plus 2, because the 3's go away and we subtract another x.
Are you talking to that thing?
I'm making a video.
So they caught everything that we just said?
No, I pause it.
You calm down?
No. And so from here we have the square root of x plus 2. We divide that 2 out of there, so we have negative x. Square both sides and then sort of repeat the process that we did before. But again, I think graphing it would probably eliminate a lot of our trouble. So that's our 6D notes. The rest of this is homework, even the word problems. And let me know if you have any questions, and best of luck. Take care.